Hello. Hello, everyone. Hello. I hope you can hear me. I hope you can hear me. Hello. So, in the last time, I hope everybody can hear me. Hello. So let's see. Okay, fine. So we are going to start. So since most of you can hear me, so in today's videos, what we are going to do today, we are going to look at the structural analysis. So in this case, we look at the tilt derivatives as well as the total horizontal gradients, which you can now able to use to delineate some linear features, which include fault or lineaments. And that is what we are going to do. We're going to merge these two in order to get out the linear features, and then we'll correlate it with that of the Euler deconvolutions, so that we're able to have a better result. And that's what we're going to do. We'll start first with our residual. From there, we'll get the yield derivative. Then that of the total horizontal gradient. First of all, let's go to the ArcMap. Go filters. You can see we have the horizontal gradient, total horizontal gradient. When we click on this, supposed to see something show up. We have two. The gradient magnitude is what we want. Click on this question mark. As you can see, this is what it means. And that is the other derivative. Look both the horizontal and that of both the horizontal along X along Y, and that is doing. So we need to select that of the magnitude. Then the input grade is our RSS, and the output is going to total horizontal gradient. Then X, Y. Then we'll click OK. So now this is what we have. Then we have this other horizontal gradient. And what it does is that it is maximum over contacts or other under contact or fault or linear features, where the maximum values is where it is going to show that that place is a contact. Of course, There's a way we can do that. First of all, let's just try to reproject this one into lat long. Utilities, reproject. Then we'll take this one to render gradient method next. That is still in projected. Then now we put it in THG into lat long. Then click next. Then to place geographic, then OK. Then finish. Now we have this grid. Then we need to create a map for this. Then we'll hold this and then we remove. Then we'll take the map, new map, scan grid. Then we have this. Okay. Look up next. Scale. Then I'll give it the name THG. Then I'll click on finish. So click on finish. You have click on finish. We're able to get our data will come to map tools. Base map, draw base map. Then the right, I'll give it 5. The left is 2. Ethics. Annotation, we'll give it positive. X is east. Then next. Then we'll call it the THG map. With that, we can change. Then we have finish. The map tools, grid and image display, single grid. Then we select the grid from here, THGLL. Then click more, shadow effects, increase the vertical scale factors. Then click on current map. So that we can set the legend. SI unit is nanotesla per meter. There we click on this, we increase the decimal place. The 3, we can put it 3 or 4, whatever we have. Let's leave at 3. Then click on locate. Then click here, then click OK. So now we have this. Then we'll click on this map. Then we can move this one where we want it. Of course, you can see where you see this purple red color. These are actually contact places you see. It's going to be maximum over those contacts. And that is one way of getting this. Then now we go to IGS MSD to save it as a map. So let's wait. So let's wait. Okay, now we'll select this 3 dots to save it where we want to save it. Then go auto maps. Then we can put our maps here. Save. Then click OK. Remember, you have to put it into lat long, then create a map. Because you will see where we're going to combine another one in order to extract those lineaments. Okay, so we are able to get those ones. Then file. Okay, let's wait first. So we close window, close all. Because no. Here we say all. So we have this. What we have, the next now is going to go back to our grid. Now we need to get the tilt derivative. In that case, we go to ArcMap. There's a tilt derivative here. What it does, if you click on the question mark, you can see this is the method uses, and these are the references where the method is applied. And the value ranges from pi over 2, pi is 3.142 minus 1.32 to around 1 plus 133. And let's make use of the vertical derivative as well as the total horizontal derivative. So what it does is that at the zero values are where the contact are. While on the other map, so where the zeros are, and that is where the contact are on this one. While for this one, where the ice values are where the contact are. So we are going to combine the two to extract the lineament. First of all, let's get the field derivative, select the input grid, residual, then give it the TDR as being suggested as dr, lat long, xy. Then this one can give it any name as been suggested. You can give it any name, HGTDR, which you don't need. They will leave everything and click OK. Now this is what we have, is HTDR. Then click on this to remove this. Now this you can see, this now is our tilt derivative, where the zeros, they actually represent that of the contacts of fault lineament. So we need to first reproject this one. Then from there, we'll take this TDR next. Then it's already projected. Then next we have TDR lat long. Then OK. Then finish. Now this is what we have. So I think we don't need this TDR in XY, we'll remove it. Don't need this again. Remove this. So we have this. Let's So we are back. So just click on scan grid. Select this one, TDR. Then we'll click next. Then we'll scale. Then we'll call it the T derivative. Then we'll click scale again to confirm. Then click finish. Now go to map tool, base map, draw base map. Then here we'll call it 5. Here we'll call it 2. Then east, everything is okay. Then TTR map, which you can change in ArcGis. Then we'll go to map tools, single grid. Then we'll select the field derivative. Select this one, increase the shading. Click on this calculator, minimize current map. So now, okay, now the unit here is radians. Radians. And let's click here to increase the decimal place to 4. I'll crop locate. That will come down here. I'll click. Move this up to say OK. So this is what we have. Okay. So click on this. That will move here. Okay. So now we're going to use this one. Let me click on this. So this is the map. Click here. So we have the map, which is this, which is the tilt derivative. As you can see, the value ranges from minus 1.1 to 1, which is okay. So that is minus pi over 2 to pi over 2. And now the 0 here are actually the contour, actually the contact. So how do we bring them here? So we have to go back to map tools. Contour, then I'll click on contour. Then the input grid here is the list. There are multiple values, say the exact values. Then the smallest, we set it at 0. Then click on options. Move next, okay. No, click on line styles. Click on line styles. Then click next. Click next. Then finally on this one, you set it to yes. That is should show the level 1. Then click finish. Then click OK. That will bring them here. So the contour are inside. If you zoom out, if you zoom in, you can see them here. So let me zoom in. You can see those contour here. So those contacts are actually where the 0 contour is. Then let me bring back to the main view. So this is what we have under our tilt derivative. The contour you see 0 are actually the contact. Then we are going to export this one first as a map. Then go to this. Then now go to maps. Then now close the TDR. Then OK. So we interpret them separately. And now we are going to superimpose. We export them in order to get the lineament. And let it be safe. Now it has been safe. Then let's go to Windows. Close all. No. Then all. So you see, we have this. So now we don't need this now, is to remove this. Then now we need to bring that our other grid, which is total horizontal gradient. Let's look for a total horizontal gradient. Lat long. So we have this. So this is our total horizontal gradient lat long. Then I'll go to this map, TDR. Now our target is to superimpose this one on this map, and then we export and see. Now what we're going to do is to take this 0 contour and then put it top of this and see where do they intersect. Those where they intersect is actually contact or fault or lineament. So we are comparing 2 different methods. Wherever this, the maximum here at the contact or fault lineament. While in the other maps here, the 0 contour actually there. So these two have to be correspond for us to delineate the lineament here. So we start with this. What we do, we right click, toggle map view. As you can see, if I move this one to the right, there is a contour here. You see the contour. I can off the contour. They will go, I'll bring them back. But I don't need this field derivative, I will remove it from here. As you can see, I've removed them. Then when the map is selected, I will go to grid and image. I'll go to map tools, single grid, go here. Bring in the other one, which is the horizontal gradients. But yeah, we don't need a color bar. We only need to apply shadow. Click on this. Shading effect. Click on this. Now you can see I'm bringing this without the color bar that will put current map. Now you see, this is what has been superimposed on top of it. So now what we need to do is to go here. What's why I selected, we'll go here, we're off the base. All those coordinates, we can take care of them. We can remove the coordinates. Only the contour. If you go this, the data will go. All we need, we have off the base, we have off the titles, we are off the color bars. All of them, you off them. And the not arrow, we don't need them. The scale bar, it has gone. Everything has gone. So this is what we are left out with. I remember it's geographic. So now this is where they superimpose. And this is what we are now going to delineate our lineament. You have to see. So what you have been off, make sure that under the base, if you bring back the base, all of them will come back. But what you don't want is just to take this one and off them and then export. I'll go to map, export. Then not JPEG, they'll come to GeoTIFF. Then click on screen, then change this size to 460 so that we have high resolution. You select this full map, then click OK. They'll go to under images, and now we call it TDR, superimpose with total dental gradient. Click on save. So we are good to go. So let's see whether you have a question to ask. Okay, if you have any question to ask, let's see. So any question? So let's see whether you have any question to ask. So if there's any question, you can ask so that you can still go about it. Now let's go down. Now let's open our this man, Qgis. Now we'll go to layer. Want to bring that one. Of course, it's not a vector, but it's a raster. Select raster, then go click on this three dots. Go to the desktop where we locate it. Desktop. Go to the project, which is this. Oasis Montaj project under images. So can narrow it down here to GeoTIFF format so that we can see it. Now this is what we have. Where is it? This is the one. So you can see if we open it, then add. You see, so this is what we have. Now you can see this is what we have. But now we have two. So let this remove this one. Remove layer. Okay. Then right click, zoom to layer. As you can see, you see now the correlation here between these two, where this line, the deepest color, you see this purple layer, that is where it cut across this blue, and those are the linear features we are going to delineate. Where there's correlation, you can see them here also, and many areas see them here. All these are linear features we want to do. Okay, so can save this first on the go back one more time. Let's see on the QGIS project. QGIS project, then TTR THG contours. So that we save it. So let's click on this question mark. We'll select this WGS. Move it up and select OK. Then right click to confirm layer. It's already this. And where it's selected, we'll save it. Then go to layer, create layer, new shapefile layer. And now we'll select these three dots. Then we'll go back to this. Then now we are going to have let's put them under Oasis Montaj projects. Under here, we'll create a shapefile. So that we'll differentiate the shapefile from the geological map. Shapefiles. We have lineament. So we have this. Then the geometric type is line. Is WGS. Then we are good to go. And click OK. Now right click on this layer. It's unknown. We set. Then we'll click on this. Now we'll click OK. Then save. Then right click again to confirm. Okay, WGS 84. Right click, layer WGS 84. Now we go to delineate. We are going to now delimit our lineament from here. So click on this, double click. We'll give it a color, simple line. I'll give it a color of, let's say, 56. Then the color, I'll give it white. So if you like, you can make it 4. So apply, then OK, then you save. It means that you have this one. Then now we're going to look now to delineate fixtures. You can see. You have to zoom. You can see this one. Actually, this is a lineament, as you can see, where the zero contour of the t derivative is exactly on the maximum of the total horizontal gradient. So this one, there is good correlation here. This will be a particular lineament which you can delineate across this area. To do that, we'll click on this. Let me see whether if there's any question. So anybody have a question? So let's see whether there's any question to ask. If there's anybody, then now from there, we need to delineate this once. How do you do it? We'll click on this edit, semi-selected, then click on this line. Then we'll take from here, we click, move it to this point, click, right click, then done. Now this one, we have another one here. Click on this, right click, done. Then click on this, right click, done. Then click on this, right click, done. So you're going to do this way, where those lines, except with that of the purple color, the eyes, also this point. Also this point. Also this point. So that is the idea of this. What you have, you can click on this. Click on this, right click when you are done. Then you can hold the space bar, drag and move. Then let go. Then now you move to the other ports. See those pointer, you click, right click, done. this point, right click, done. Then this point to this point, right click, you are done here. Then this point to this point, right click, done. This point to this point, right click, done. But then roughly we can take this point. So there are many others. So the idea is for you to be able to understand it and do as many as possible. You can come back at any time and add more. You want to add this point, this point. So this is the point. So this is the best way of doing it. Combine all methods for this point, this point, to this point, for this point. For this point. So this point, for this point. So, and that's where you have the correlation. So you hold down the space bar, you move to look for other point. Then you let it go, you right click to cancel it. Then you click here, right click. This is a point. Then another point is here. Right click, done. So now I think we're done with this part. Then we take this part. We also take this part approximately. This will also be 1. This one is a good correlation. So this one to this one is another good correlation. This one to this one is a good correlation. Then this one, this, another one. This one to this. So you have got a point. Let's see if there's anybody that have a question to ask. So any question? So do you have any question? So let's see if there's anybody that have a question to ask. So we do this, then we take this one, we are there. Take this one, we are there. Take this one, we are there. Take this, we are there. Take this, we are there. So the idea is to take as many as possible. We can take this one, this, click. We can take another one, this, and this. Click where they intersect, this. So yeah, let's save here. Then let's stop. Click on this back, then save. Then click on this zoom to layer. We have this. So even though there are some other ones here, you can still come back to them. See, if you zoom, you can see them. You can come here and do. So anywhere you want to do it, you can do it. Has been saved. You can come here, add many other ones, and you go and you finish them. So now if you want to show alignment, you click now on this, click on this, we change the color. Shade of this, can now give it black. We'll give it to 2626. Then applied. Okay. Then we off this layer, and this is now our lineament. Zoom to layer. And I see, so this is the lineament being extracted, part of it. You can still come back, bring this one, and continue, do the other ones. You change the color to white, and that is the procedure. We have saved it. So now you can bring this one in any of the maps that you have. You go back to this. No. Then go to window, close all, none, because we don't want to edit this one. Then click on this. And what we do again, so the time now we can now take our, let's see whether we have done the first, we have done this one. And now is to add this. Let's see whether we have done the first vertical derivative. It's not there, so we can do the first vertical derivative. First vertical derivative, xy. First vertical derivative dot con. Then filter. Can I bring that lineament on top of that first vertical derivative? Then we'll look to derivative here. Is order one vertical, okay. Then click OK. So you can see this is what we have. Then we project this one. Filter, reproject. Click the vertical. Okay, it's already projected. Then now push it to S vertical derivative lat long. So move to geographic. It's going to be under geographic. Then that is it. Then finish. And this is what we have. Then we hold this one, then we remove. Then we'll create a map for this one. Scan grid. Native, then OK. Then click next. Scale. First vertical derivative. Scale again. Finish. Map tool. Base map. Draw base map. Then we'll create this one 5. Then we'll take the left to be 2. Then OK, everything is set. I'll call it the first vertical derivative map. Finish. On the map to grid and image display single grid. We'll take the first vertical derivative. Now we add the color bar. We'll change the decimal. We'll change the shading effect. Click on this. Show less. The current map. Now the unit is nanotesla per meter. Of course, we can leave the decimal place to 4. We can put to 5 if you like. Then click locate. Click down here. And this. So this is what we have. Then we'll click on this. Now we have moved this somewhere. Yeah, then I'll click on this. Okay, to this, you can see we have this. Okay, now is to bring back that lineament. They go to map, import. We can bring it out, we can still bring it anywhere we feel like taking it, so I think we can leave it there. Okay, so here is can see come to ArcGIS MSD, save correct map. Then here we have maps. I will save it. Okay. So now I'll go to Windows, close all. No, all. Okay. So this is what we have. Then now we don't need this. We remove it. So this is what we have. Project save. We have our this save. Now if we go down to our images, now we can see that of one of them with magnetic. Let's see the GMI map. Okay, it's 12 minutes. 12 minutes. Okay. Now let's open our ArcGIS. Go to File, Open. Then Desktop. Let's go to Parastate, OSM project. Then Maps, first vertical derivative. Okay, so this is what we have. Now we can select this. We delete. Insert the not arrow. Double click. Here we now insert the scale bar. I've create one, then I've saved it. You can create any one and then add it. I have my own save. Now we can crack, then bring it down here. Of course, we can change this one. Let me first off this one, then click Insert, Text, click and just type, then click outside, double click, lineament map of the story area. I click symbol, change to 14, make it bold, then OK, then apply, then OK. Move it down here, then click on this, delete it, bring it down here, OK. Click Save, bring back the grid. Now let's click on this, then we'll remove it. And now we'll right click here to bring our own coordinates, work to format. Then click next, next up to finish. Then go back to properties. Under labels, change it to 12. Left, right. Under lines, do not show lines. Under intervals, go degrees and minutes. Change this one to 12 minutes, 0 degree. Then click applied, then OK. Applied, OK. Then you hold down your shift and then move it down a bit. Hold the shift, move it left or right. Hold the shift down, bring it down, and position it anyone to. Can now align it. Hold down the shift and use the arrow key to move it up and down. You align it, then you click save. Now let's off this layer. Let's put our data. Let's go back. So now you can bring back our towns. So our towns is there. Let's go back to this. Let's go one more time up. Stamara OSM project. Shape files. Lineament. Then we add. So you can see, then double click on this. Then change the color to this. So if you like, you can change it to 1.5. Then OK. Use a lineament. Then double click on this. Click on this cycle, then bring it down to maybe around 10 or 9. Okay. Then double click on the towns. So we're going to plot 3 maps M. Then label these pictures. You can put it 12 and apply. Okay, so those are the towns we have. Then let's bring the legend, insert legend. So we have lineament. Oh, let me cancel first. Click on this lineament. Let's change that letter to be capital letter. Double click on it. Under general, then click on this, change it to capital. Yeah, I think lineament is okay. Click this, okay. And let's put that inside the legend. Now this is what we have towns this, then click next, 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 finish. Then you drag it down and bring it somewhere here. Move this one to the left. Double click this one to change the font size. Take the towns first, or you can select all. Select all, then go to symbol. Then change this to 12 so that it become bigger. Then apply it, then OK. As you can see, you can hold the shift key to move it up to align it. So this way is OK. Okay, this is the first map. So this is the lineament map of the area. Like I said, you can still go back, you edit this one and add more and save it and do the import. And that is way of adding more. Okay. So now we go to file. First export this one. Because you see I'm coming first. So let's bring out first this map first before we delete. You see this what we have first. This is the map where the towns is there. So we need to move those towns above. Move those lineaments also above. So they are there. So they are there. So if you like, you can change the color to white. Depends on which one you want. If I change the color to white, let's see whether we can see it white clearly. So you can now see the linear features there. Then for the towns, I can edit the town better. Labels, okay, symbol, edit symbol, advanced text background, properties, changes to 1, changes to 1, Change this to 1. Change this to 1. Symbol. Fill color is white. Outline width is 0. Then OK. You can see it. Then OK. And give it a little of shadows. Then OK. Then we have now press OK. Then applied. Okay, you can see them now. This is what we have. Towns and the legends. So this is a best part. You can double click on this. On the right, first vertical derivative map. Out of space, we just put the map, only map. Okay, this is what we applied. Okay, this is what we have. So now save it. So we have all this one saved. Then we'll come to File, Export, Map. So you see the lineament there, the color is this. So we need to change those colors so that we can see it there. Change it to black. Then change this one to 2. And OK. If you like, if it's too big, you can bring it to 1.5. Then OK. Then save. Then file. Then export map. Go back. Go the images. Magnetic. There's vertical derivative. And that's what we have. So we have this. So if we open our folder, go on this, view extra large. You see, this is the first vertical derivative map showing the lineament. I see the white color not showing, so it's better let's change the white color because of the colored. And still double click on this and change it to white. Click save. Then file export map. So we can just overwrite it. Select it, then override 460 dpi. So override yes. Go back to our first vertical derivative, which is this. So now you can see it. Now you can see those linear features here actually delineated. You can see them. So those are the linear features overlying the what and the vertical derivative. There are some others we have not done around these areas. You see some of them actually on this. So showing the lineament and the rest. First vertical derivative map. So you can go and delineate those other ones. And now let's export only the other one we need. In this case, what we do, we don't need this one, we delete. We off this layer. We bring in the lineament, change the color now to black. But don't save it. You only export it later. You see, you don't save. Then change this one. Lineament. The study area applied. Okay. So now you can hold this one and then move it, position it, center it. Or you can Control Z. Take this one, then bring it down like this. So like so is okay. So this you can now come to File, then Export. Then now we'll call it lineament. Lineament. Okay. So these are the lineament map. Not that of the geological lineament. So this is what we have. So this is what we have. So now is if we check, folder we have the lineament somewhere there. And this is the map. As you can see. So those are the linear features that has been delineated for our map. So look, the legend is how we do it. So let's see a question, whether you have any question. Let's see, is there anybody have question now? How do you compare with that of the EULA? So we have done with this, you can come and add and save and repeat the same thing. Let close, then let's go back to this. Now let's open. Voila, you can just create new. Don't save, blank, okay? Don't save, okay? So leave it the way it is. Now we'll go back to data view here. Then we'll click to File, Open. And let's put EULA 2. We're going to superimpose again the similar thing we do here. You can see this is what we have before initially. Now if we bring our our data, share files, lineament, then add. As you can see that there, if you click on this, change the color to 1.5, then change this to black. So this is what we have. Then here we double click on this. So we can change the name and give it the legend, general, lineament. Then insert legend. It's only lineament, next, up to finish. Double click. Then click, select the item here, then click symbol to change the font size to 12. Then click OK, then apply, then OK. So this is what we have, this is the legend. Okay, we can leave it like this. So on this, we don't need it. We can just go insert, not arrow. We'll click on this. Just want to compare and construct and see different methods. Okay, so this is what we have saved. Then export map. So this is how to compare all the methods and make sure that your lineament is in the right way. Let's export. Now we call it to and lineaments. See, different maps, lineament. Okay, so this is what we have. Click save. Now we have saved it. Okay, so if you like, you can just change these names, Euler solution, superimpose on the lineament, or any name you want to give it. So we'll go here, we'll look at so this is the one we'll look at. If we check now, you can see the correlation here. These linear features has already been delineated. Some of them, you see them. That means everything works perfectly. So some of them have not. So by the time we increase other one, we can able to get some of them here. You see them? That large feature, that prominent one, yeah, actually is being shown here. That is this one. If we go to the, I mean, to be able to see them here, this is a prominent one. This one actually been delineated in both all the methods. So we have confidence that this portion is actually features to look into. And also, if you look at some of that, you see them, accepting with those one actually arrange, and that shows that yes, everything works out good. And that so if you do the other ones, normally you get similar result. So this how to do the other thing, compare your result and the rest. So I think this is what we have. Can now close. Okay, we have finished with what we have. So this how to do the structures map of the study area. We are still doing it. Okay, so therefore, if you are not joining, I think this is where we are going to stop. So we are going to stop here. So I think so this is where we are going to stop. Okay. See you next time.